All right, let's look at the homework 3.7, problem number 9. All right, so we're going to start with the middle sheet of with 30 centimeters, and we fold the 10 centimeter on both sides to create a gutter. All right, so we want to find this angle theta so that the capacity is the maximum. All right, so let's do that. All right, so in order to maximize the capacity, we basically want to maximize this cross-sectional area, which is a trapezoid, right? So we know that if this is theta and this is 10 centimeters, so this is going to be 10 times sine of theta, and this length is 10 cosine of theta. All right, so we can find the area of this trapezoid in terms of theta, which can be written as A of theta is equal to, all right, it's 1/2, all right, bottom base 10 plus top base is 10, and 10 cosine of theta, another 10 cosine of theta, so it's a 10 plus 20 cosine of theta times height is 10 sine of theta. Alright, so this can be simplified as, let's see, so you have a 10, so you have 10, 20 divided by 2 is 10, so 10's pulled out. So 20 divided by 2 is 10 pulled out, so it's 1 plus cosine of theta times the 10 pulled out, so it's 100, and the sine of theta. Alright, then so we want to maximize this cross-sectional area over theta. Theta can go from 0 to, we don't want to exceed pi over 2, so we can just do on, say, 0 to pi over 2. Alright, then let's look at that. Alright, so we take the derivative of the cross-sectional area. So that's going to be, so 100 is just a constant multiple, right? So derivative of 1 plus cosine of theta is negative sine of theta times sine of theta, so squared, right? Plus 1 plus cosine of theta times derivative of sine of theta is cosine of theta, right? So what we get is this. So you have 100, right? Negative sine squared of theta is equivalent to cosine squared of theta minus 1. And here, cosine is distributed, so it's a cosine of theta plus cosine squared of theta. Right? So we can actually rearrange this so that there's a 2 cosine squared of theta plus cosine of theta minus 1. We can actually factor this guy out. So if you factor it out, you get 2 cosine of theta and a cosine of theta here. That would be plus 1 here, minus 1 here. Right? We set that equal to 0 to find the critical value. So one is we want cosine of theta to be 1/2 from here, or cosine of theta to be negative 1. Right? Right, so cosine of theta is 1/2, so angle would be, let's see, let's do the number line, not number line, unit circle. All right, so you have a unit circle. Cosine corresponds to the x coordinate, so we want 1/2 here. So we want the angle either here or here, right? But angle is between 0 and 2 pi, so this angle is pi over 3, right? So we know that this is pi over 3. And here, if cosine is negative 1, theta is pi. Actually, that's too big, so we're not going to consider that. All right, so pi over 3, So let's do the number line. So from 0 to pi over 2, right? 0. And the critical number is pi over 3. Right? So if you look at a prime, right, then if you plug in anything smaller than pi over 3, like a pi over 6 or something like that, and if you put pi over 6, so smaller, so this is going to be positive, right? And this is going to be cosine, so that's going to be positive. So we know that this is positive here, right? After pi over 3, so something a little bit bigger, so that's going to be negative, and this is going to be positive. So the derivative is negative, right? Which means that area is going to be increasing before pi over 3 and decreasing after pi over 3, which means that we have a maximum here, right? So we want angle to be pi over 3. Right, so let's type it in. So answer is pi over 3. Submit for testing. All right, it came back and looks like we got this angle correctly. All right, that's it. I hope that this was clear.